The hallmark of the endocrine system is the secretion of signaling molecules known as hormones directly into the bloodstream. One of the 6 hormones released from the anterior pituitary gland is thyroid stimulating hormone. TSH is a tropic hormone or trophic, depending on the book you read. And a tropic hormone is a hormone that stimulates the release of another hormone. Now, certainly, hormones will elicit a whole host of downstream activity, but one of them could merely be stimulating the release of another hormone, and that's exactly what TSH does. So TSH, when it is released from the anterior pituitary, is immediately going to proceed into the bloodstream, because that's what hormones do. They get moved into the bloodstream so they can be distributed throughout the whole body. Once TSH arrives at the thyroid gland, which is a butterfly-shaped gland in the anterior aspect of the neck, it stimulates the thyroid gland to release thyroid hormone. When thyroid hormone is released, it moves directly into the bloodstream to stimulate growth, development, and a bunch of metabolic activity throughout the body. If we take a closer look at the thyroid gland, interior, it looks like this. What we see in purple and in green are known as thyroid follicles. Around the perimeter of the thyroid follicles, we see follicular cells, which are a specialized simple cuboidal epithelial cell. And in the middle, it's filled with a substance known as colloid. These follicular cells are going to be the cells that produce and release thyroid hormone upon stimulus from TSH. There are 2 types of thyroid hormone: tetraiodothyronine, otherwise known as thyroxine, and triiodothyronine, known as T3. Thyroxine is T4, triiodothyronine is T3. Collectively, we refer to both of those as thyroid hormone, which once again is going to stimulate growth, development, and metabolic activity throughout the body. So that is the axis or pathway related to the pituitary. The pituitary, specifically the anterior pituitary, is going to release TSH, which stimulates the thyroid gland, specifically the follicular cells of the thyroid follicles, to release thyroid hormone. Between thyroid follicles, we find the parafollicular cells, para referring to the side. So these represent parafollicular cells, which secrete calcitonin into the bloodstream. Calcitonin is a signaling molecule released into the bloodstream. Calcitonin is released from these parafollicular cells during times of elevated blood calcium. And calcitonin will cause that blood calcium to be stored or deposited in bone. If we look at the posterior aspect of the thyroid gland, we're going to find parathyroid glands. Officially, they are not part of the thyroid gland other than they are embedded on the posterior aspect of the thyroid gland. The parathyroid glands release parathyroid hormone, which is released upon diminished levels of blood calcium. So when parathyroid hormone is released, it breaks down bone to liberate the calcium to put it in the bloodstream so the body can use it, and it increases intestinal absorption of calcium. Parathyroid hormone is released from the chief cells of the parathyroid glands. That is not to be confused with the chief cells of the stomach lining. So in review, we have TSH from the anterior pituitary that stimulates the release of thyroid hormone from the thyroid gland. Totally unrelated to that anterior pituitary axis are the parafollicular cells and the parathyroid glands. The parafollicular cells which are adjacent to the thyroid follicles, hence the name parafollicular, release calcitonin during times of elevated blood calcium levels. The parathyroid gland, which is on the backside or posterior aspect of the thyroid gland, releases parathyroid hormone during times of diminished blood calcium levels.